Okay, we are going to do use the first partials test to find any relative minimum or sorry, the second partials test to find any relative minimum or maximum values on this uh, function right here, this multivariable function right here. I have two videos that go along with this one that you should have watched previously, and these are two examples. So, first step, remember, here's the second partials test. It's to find relative minimum maximum saddles. I calculate a D. First thing I do is I find the critical points. It's where both second partials or both first partials are equal to 0. Then I calculate this D, which is a determinant. That's what that green is. I go positive that way and negative that way. Excuse me, this way. And then I have 4 cases for the D. So the first thing I need to do, and I think we did this one earlier, is find f sub x. That in this case is negative 6x. And find f sub y, and that in this case is negative 2y. I think it should be pretty clear that x equals 0 and y equals 0 is the only thing that will make both of these first partials equal to 0. So that means that my critical point, there's only one of them, is 0, 0. So from here, I need to then calculate the second partials. Well, f sub x is the derivative of this thing with respect to x, and that's just negative 6. And f sub y is the partial of this with respect to y, and that gives me fyy equals negative 2. F sub xy, remember, I can do that by doing x of f sub y, or I can do the partial derivative with respect to y of f sub x. Either one of those will get me there. So if I take this and partial x it, then notice there are no x terms in here. So my f sub xy is just equal to 0. Notice no x is here. Do the derivative with respect to x for this thing, goes away. No y's in this one, I could get the same thing. So, remember, I now got to calculate this d. So, in order to do that, I need to evaluate these guys. Oops, let me just do a highlighter. I need to evaluate this, and this, all of them at this critical point. Well, it's really easy because these guys are already just numbers, right? So my D, I'll write it again, is fxx, fxy, fxy, fyy. That determinant. So what's that? It is, all right, fxx at 0, 0 is just negative 6. fxy is 0, and the negative 0 here, and then fyy is negative 2. All right, so remember that is this product plus minus that product, or minus that product. So I get a 12 minus 0. That's just 12. Now, so D is greater than 0. Right? So let's go up here. What does that tell me? Oh, that tells me that I'm in either case 1 or case 2. So now I just got to look at the partial xx or the partial yy at 0, 0. So, and look, that is already right here. So D is greater than 0. F sub xx is equal to negative 6, which is less than 0. Remember, draw concave down. Oh, what's that mean? Right? So we are in this case right here. So we get a max at f of a comma b. So we get a max at f of 0 comma 0. What was f of x comma y? It was this thing. So notice that point is going to be 0 in here, 0 in here. I get a 6, right? Which is 6. So this should make sense, honestly. Like, this shouldn't be a surprise. This is a paraboloid. It opens down, and it's going to have a max. So let me show you the graph of this thing. Well, bam, right? So Notice 6 minus 3x squared. This GeoGebra grapher is really good. Just Google GeoGebra 3D grapher. I get 6 minus 3x squared minus 3y squared. And then I put a point in A right here at 0, 0, 6. So let's do one of these where it's not quite as easy to just know, oh yeah, we get a max. That makes a lot of sense. So example 2. I like this one. Let's take f of x comma y equal to negative x cubed plus 4xy minus 2y squared plus 1. All right, so what's my first step? Find the first partials, f sub x. Well, it's negative 3x squared, and then this is a mixed term, right? So remember, we treat the y like a constant, and I derive with respect to x, right? So I get plus 4y. Is that correct? Yep. And then my f sub y is equal to, oh yeah, I should have said this guy derives away because no x's. This guy derives away because it's a constant. Now my f sub y is this guy goes away. I get 4x. And then minus here 4y. So this one doesn't really factor the way the ones that we did earlier do, but it's really just I want to have this equal to 0 and this equal to 0. And that becomes a system of equations, right? So you can kind of like ignore this and think about this system of equations. And what makes it possible to solve this is, look, x and y, well, I've got 4x minus 4y equals 0. Well, I can move the 4y over and get 4x equals 4y, divided by 4, x equals y, right? So notice x and y have to be the same thing in order for both of these partials to be 0. So I've used this equation. Now what I need to do, as with any system of equations, is plug this guy right here into that guy right there. So what's that give me? Which one do I want to do? I think it's easier to say negative 3x squared plus 4x equals 0. And now what I can do is factor in x out and get x times negative 3x plus 4 equals 0. Well, there are two ways that I can make this happen. One, x equals 0, or two, if I solve that equal to 0, I get x equals 4/3. Now what I do is I take those guys, and x and y are the same thing. So that would mean x equals 0 and y equals 0. That means my first critical point is at 0, 0. And my second critical point is at 4/3 for x. And remember, x and y are the same thing, 4/3 for y. So now I got to calculate my deets. So I got two critical points. I'm going to kind of just save this for later because that was, believe it or not, only step 1. Okay? So now I got to calculate the second partials. So fxx, right? That is just equal to negative 6x. Fyy, that is equal to the partial of this with respect to y is just negative 4. Is that correct? Yep. And then for my f sub xy, I can take either one of these two up here and derive them with respect to the opposite piece, right? So I already got an x. Let me derive this with respect to y. Oh, we get 4. And then I can check it down here too. Let me derive this thing with respect to x. That goes away, and I get a 4 as well. So f sub yy, or xy, is equal to 4. So now what I'm going to do is calculate the d at the two different spots. So I've got 0, 0, and I've got 4/3, 4/3. So at 0, 0, remember d is equal to fxx fxy, fxy, fyy. So when I want to do a d equals and then use the vertical bars. All right, so xx at 0, 0, well, that's just 0. Xy is 4, and then I get another 4 here. And then f sub yy is negative 4. What's that give me? I do this plus this minus. Well, the first piece is 0, and then minus 16, which is, we should get in the habit of using greater than or less than signs, which is less than 0. So d is less than 0. What's that mean up here? That means that they're not tied together. It's this case number 3. So we get a saddle, okay? So saddle. Okay, and now let's do it at 4/3. So d is equal to bars. All right, I got to plug in 4/3 to this mess. All right, so it's actually not that bad because what's negative 6 times 4 over 3? That's negative 2 times 4, which is negative 8, correct? Good job. So that's negative 8. I just plugged in x equals 4/3 to this, and then these guys just get cut in. There's no plug in 4/3 into them. So my d is equal to, I get a 4 and a 4 again, and then a negative 4 like that. And that is equal to 8 times 4 minus 16. That's 32 minus 16. It's 16. Okay, good. So d is greater than 0, right? So I'm not going to get a saddle. Let me go up here. What do I get? It's one of these two cases. So now I got to inspect f sub xx or f sub yy. So come down here again. Which one's easier? Oh, look, I already have f sub yy. It's just negative 4. So f sub yy is equal to negative 4, which is less than 0. And then I always like to draw concave down, right? So hopefully you know the therefore sign. So therefore, we get a max. So we have this function, multivariable input function, has a saddle at 0, 0, and a max at 4/3, 4/3. So let me show you that that's true. Come over here. A moment to show up there, but here I've typed in that function into the 3D GeoGebra grapher. Ba-boom, that's exactly what we had. So I typed in, I can plug in 0, 0 to this and easily get 1. So the point 0, 0, 1 is on there, and look, boom, there it is right there. Do you see that saddle right there? Can I spin it? Super cool. And then I can come over here and B, 4/3, 4/3, and then 59 over 27, you can get it by plugging in here and just using your calculator to plug those numbers in. We get this thing, and look, B, right there, we get a max. So you should see all those spots right there. And I don't actually know what the GeoGebra is doing here with these arrows. I sort of think that it is helping us to visualize the partial derivatives in the x and y direction there. And I didn't even know it could do that. So hey, look at that. You learn something new every day. Super cool. I can test that out later. Anyway, so hopefully you understand, you can see that what we just did shows up graphically, and you understand how to do these second partials test questions. And next time I see you, we're going to talk about why.